Hey, what's up, everybody? It's the Hackster. Haven't done a video in a long time, but recently I've decided that I'm going to start making some videos, me using Revit and creating some Revit content. That's typically what I do for my day job. I create things in Revit, among a lot of other things that I do as my job responsibility, but lately that's what I've been doing a lot of. So I figured I'd make some videos of me going through and just making some Revit stuff. A little bit of background here, though, is that I'm just using my HP ZBook, and I'm using a software called Camtasia to do the recordings and to edit the videos and to compile the videos. And it's relatively cheap software, so if you haven't heard of it, it's made by TechSmith. It's relatively inexpensive, and I highly recommend it. I've been using it for several years now. There's probably some better ones out there, but for the cost, it's pretty good. And I'm using just my regular Bluetooth headset. Right now, it's the best I've got. As time goes on, and if these videos are successful, I'll probably buy a better setup so that the audio is a little bit better. Because right now, my headset doesn't really pick up very well, so I don't know how loud my audio is going to come through, but hopefully, as time goes on and I make more of these videos, that's going to improve. So let's just go ahead and dive right into it. So like I said, I use Revit, and that's the primary software that I use for this content creation. I'm using Revit 2018. I like to keep all of my Autodesk products on the same version. So all of my AutoCAD and my Navisworks and everything, it's all in 2018. And then every couple of years, we upgrade. So in 2020, I'll probably upgrade everything. I have had to download Revit 19 for some one-off projects that were made in 19 by other people. But for the most part, I pretty much use 18 to create everything. So right now, I'm working on putting together a model for a police academy. This particular project has both a fire academy and a police academy on the same site. And I've already made the model for the exteriors and the structural for the fire academy, but I need to do the same thing for the police academy now. And so that's where I'm at. I did some work on this already this week, and I'll just do a 3D view here so you can kind of see what I've done so far. I've got the piers in, they've got bell bottoms on them. I actually created this family myself, so that way I could use the parametric modeling feature to automatically resize these. See over here on the side, I can put in the pier diameter and the bell diameter, and it'll automatically adjust it accordingly, which is really great because it makes things very easy. It's like one of the great benefits of using a software like Revit is the parametric feature, so that things automatically resize as you change dimension values. And I could make a video on doing some family creations. I've done it quite extensively over the last couple of years, and I'm not going to say I'm an expert at Revit because I'm not. I know there's other people out there that are way more experienced than I am. But, if you want to leave comments on things that I could have done better or a different way of doing things, I'm always open to learning and to finding a better way to do this. So feel free to leave any comments and for the video. But yes, I put the piers in. I got the slab in. And I break the slab up a little bit just because, you've got like these walkways that are sloped. And then you've got all the different caps and the beams and things. So, if you look underneath, you can kind of see I've got the piers in. I've even got like a little edge, like a 45-degree edge that goes all the way around. So I had to break up the slab to do that. But it's not the hardest thing to do things like this. It's really just more a procedure of, what you do first, what you do second, what you do third, and that's something that you just learn over time, the best order of operations to put things in that, makes you more efficient with your time. So anyway, I guess one thing I'll also mention is, if you guys are out there looking to get into the whole BIM side of things and to learn it, the best way to do that is to buy the AEC Collection from Autodesk. Several years ago, before the collection came out, they used to be a lot more expensive, the programs, if you bought them individually. Now they bundle all of the architect, engineering, and construct programs into one bundle called the AEC Collection, and it's relatively inexpensive compared to what prices used to be. So I was really excited when they came out with that. So that's something to look into, because then that gives you a whole suite of other products that you can use, like AutoCAD and Navisworks and InfraWorks, and it's just a really good collection to have, if you do a lot of things with BIM. So that is something to look at. So we're going to go ahead and get started. Trying to figure out where did I want to go after I left off yesterday. So one thing I need to do is, you notice that there's this ridge that goes all the way around. This is actually meant for the brick facade. It's supposed to come down and rest on a ledge, but I still need to put that ledge in. And the reason why I didn't put the ledge in before was because, there are some architectural details that will tell me that there are some other openings where the slab needs to extend all the way to the edge of the foundation. So I figured I'd just kind of play with that one as I went along. Maybe when I got closer to doing the actual architectural side of things, then I would come back and put that in later when I know exactly where all the openings and the sizes of the openings, because structural drawings don't really tell me what the sizes of those openings are, so I'm pretty much going to have to rely on the architectural drawings for that. So I think probably the next thing I need to do is probably start looking at some of the beams and the columns that need to go in, and so we're going to look at that. I'm going to be kind of referencing my drawings off to the side, so I apologize if it looks like I've kind of wandered away to go look at these things, but I'm working on a laptop, and as it stands right now, it's going to be kind of hard to see anything that I'm doing on a device like a phone or a tablet. You really got to have almost a monitor to be able to see all the buttons and the things that I'm doing. So I apologize for that. I'm actually going to be making some another thing that we're going to feature on this channel that my kids have really wanted me to start getting into is start making some Minecraft videos. I've been playing Minecraft for a couple of years now, and I've been following other YouTubers that play Minecraft, and my kids are like, well, why don't you make your own Minecraft videos? And it's just not something that I've really thought about, but it's something that I've thought about a lot lately, and thought that maybe I would give it a shot and dive into it, maybe try to find a server or even make my own server and start doing some Minecraft videos. But I'd rather get on a server with other people so that, it's more interactive and can see what other people are doing and interact with other people. So let's see. So if we go back to my floor plan view, so I'll go back to level 1, you're going to see I've got all my grids set up. The grids are great because they allow you to know exactly where the piers are going to go and columns are going to go. And then they've got some intermediate column lines. They don't actually draw them out as part of the grid, so I just use some reference planes to be able to put those in. So those are just, I guess, kind of temporary, although I'm going to leave them there in case I need them. So I'm looking through a wireframe view at the bottom. So if I want to change this back to a shaded view, that way I don't see through everything. You can kind of see top down what I'm looking at. So I need to put some hollow steel columns around the outside, so I got to look at my drawings to see which ones I need to pull in. So it looks like, according to the drawings here, that I need some 6 by 6 by 3/8, some 5/16. Let's see, what other sizes do I need? I need a half. And the interesting thing about doing this too is you really got to decide what level of detail that you really want to get down to. And, I tend to not necessarily err on the high side, but one thing that we also do here is we do the 4D modeling. which is when you put the model against the schedule and you can see the model being built over time. And I kind of try to keep that in the back of my mind as I'm doing this because I want to make sure, that we are putting enough detail in there that, we can be able to assign it to schedule elements and be able to get a real feel for how the project's going to go together. So that's something that I've always got in the back of my mind. So there's a couple of 6x6s, but there's also a couple of 8x8s. I'm just writing this stuff all down so that way I can just grab it all at once. It's a 3/8, it's a 5/16. Okay, I think I've got everything. So what we're going to do is we're going to go over to our Insert tab. We're going to load a family. And these come with a whole bunch of preloaded family, or not preloaded, but they got a whole bunch of family libraries that you can go through. So I'm going to go to Structural Columns, and it's Steel, and it's the HSS Hollow Structural section. Yeah, I don't want to use the round one. I want to use the square one. So we double click on that, and then it's going to bring up a window asking, okay, well, which sizes of these do you want? So then I got to go find the ones that I wrote down. So they're all going to be smaller than that. So let's see, we got 6x6, and we got 5/16. And if I hold down the control key, I can select multiples. So I've got half, I've got 3/8, I've got 5/16, and then in the 8x8 size, I've got half and 5/16. You know what, I didn't want that one. I want 8x8. 8x8 by half, 8x8 by 5/16. Okay, so I think I've got them all. So I should have 5. Yes, I've got 5. Okay, so then I click OK. And then it brings them in. So now they're available. So if I go to Structure and I go to Columns, I've now got them in my list here on the side. And so I'm just going to start putting them in on where they go. So this one on the corner is 6x6 by 3/8. So we're going to click that. We're going to put it in on the grid line. Fabulous. And then the next one I put in is a 5/16. And that one's going to go on this grid line. And then the next one, again, is a 3/8. So I'm going to go to 3/8. Click on the grid line. And then the next one is also 3/8. Look back at my zoom here so I can see where I'm at. Okay, so I need to put it there, and I need to put it there. And then the next one is going to be a half. And I know you're probably thinking like, well, this is way too much level of detail. Why are you putting the exact sizes in? Does it really matter? The reason for that is if we decide to put together a schedule of values, then they're actually going to be sized correctly. So that's why we want to make sure we get the right sizes in there. So we got 3/8 here on the corner. Let's see, and then this one is also 3/8. And the bottom one is also a 3/8. And then that one's a 3/8 as well. This is a 3/8. All right, so then we're going to actually go to a half. Sorry, I'm just looking back and forth at my other screens. So I apologize for that. Let's see, and now we're going to get into some of the bigger sizes. So some of these over here are 8x8 and not 6x6s. So we got an 8x8 by half. Just going to go in right here. And then on this corner, we have an 8x8 by 5/16. And then those two, let's see, 6x6 by 3/8. I have. Then we have a 6 by 6 by 5/16. Goes in there. And a 6 by 6 by 3/8. Goes right there. We have a 6 by 6 by 3/8 again. It goes right there. All right, so we did all the ones for the perimeter. Now we're going to get some of the ones that are in the middle of the building. So 6 by 6 by 5/16, that's going to go right here. And then we'll have a 3/8. Yeah, so 3/8, and then we're going to get into some of the bigger ones. So do 3/8, that's going to go here. And then these two are actually 8 by 8s. So we got some bigger ones that go here. Bigger one, that's bigger one. Got to hold up all that roof. And then we go back down to 6 by 6. So 6 by 6 by 3/8. It's going to go there. And then this last one is going to be a 6 by 6 by 5/16. It's going to go right there. All right, so now we got all those in. So if I go to my 3D view, you're going to look at that and go, where do they go? Where are they? Well, it's because they're kind of hidden under everything else. So it's trying to put them at the wrong elevation. So what I got to do is I got to go back to level 1. And I'm going to select all of them. So we're going to select all instances in the entire project. And then we're going to select that one as well. And I need to select all these different sizes here. So I got that one. I need to grab that one. So another way to do this would be to place one, make sure that the settings are correct, and then just kind of copy and paste it around, and then just go around and change the sizes of each one. But that's not how I chose to do it. You know, that probably would have been easier, but you know, live and learn, right? It's all a learning experience. So I've got that one, I've got that one, that one. Okay, so I think I've got them all. So what we're going to do is, for the base level, I want the base level to be level 1, and I want the top level to be the roof. Okay, so now I've got that changed. So if I go back to the 3D view, you should be able to see them all now. Make sure I didn't miss any. Oh, I think I got them all. Now, I don't know if these are actually going to the roof. I'm just putting it that way for the time being. I can always make an adjustment to how tall they are later, but that just gets them in there for now. So the next thing I need to do is start looking at the structural steel. So, interesting. Anyway, so go back to what I was doing. Got to go to the structural steel drawings and got to see what we've got going on for structural steel. So, let's see, we got a couple of wide flange beams I need to grab, so I need to take down what the sizes of these beams are. So we got a W18 by 35, and we got a W14 by 22, and we got a W21 by 44, got a W18 by 50, and we got that one already, so we got W24 by 30, or 24 by 55, if I can get that right. And we got 21 by 48. Got that one already. 24, 55, 18, 50. Got those already. 14 by 43. I don't got that one yet. 14 by 43. Let's see. 16 by 26. I got a 10 by 12. Yeah, I got that one already. 18 by 35, 21 by 48. Got that one already. 21 by 44. Let's see, 18 by 40. Don't got that one yet. Okay. So we also have some other HSS tubes that are also going to be used as structural members, so I need to grab those as well. So 16 by 4 by a quarter. And then they've also got 14 by 4 by a quarter. And I think that's it. And then they've also got some K-series joists that I need to grab as well. So let's go ahead and write those down. So they got 28 K9s. They've got 22 K5s. I apologize if the screen's not moving because I'm over on this other screen just getting down all the stuff. They got 30 K7s and I got 26 K7s. Where I got that one? Okay, so I think I got everything. All right, so let's go ahead and bring in all these framing members. So I got to go to inserts. I got to go to load family. This time, instead of doing columns, we're going to do framing. And it's going to be steel. And so we'll grab the wide flanges first. So let's go with the biggest as we go down. So the biggest one I've got is a 24 by 55. And there it is. And then we'll hold the control key down. 21 by 44. There it is. Also 21 by 48. And then I need to go down to the 18s. I got an 18 by 50. I've got an 18 by 40. Got an 18 by 35. Then I go down to the 16s. I got a 16 by 26. In the 14s, I've got a 14 by 22. And in the 10s, I've got a 10 by 12. All right. I think I got them all. Let's see, I grab a 14 by 43. You know, I thought that might have been a typo when I saw that, because I think there was a 43. Well, let's go back and make sure I didn't write that down wrong. It says 14 by 43. I'm pretty sure they meant 14 by 34. I think that they got dyslexic when they wrote that one down. So we're going to be 34 instead. I think that should be all of them. Okay, so go ahead and hit OK. I'm going to go back to load family. This time we're going to bring in the HSS tubes. So I've got a 16 by 4 by quarter. So 16 by 4 by quarter. And then I've got a 14 by 4 by quarter. 14 by 4 by quarter, right there. 14 by 4 by quarter. All right, so those are the only two I need in there. And then I'm going to grab my K-Series joist. And for this, I'm going to grab a 30K, I guess it started from the low end. So 22K5, 22K5s, and then there's a 26K7. There's that one. And then I'm going to grab a 28K9. There's that one. And then a 30K7. All right, so that should be all those. Bring all those in. All right, so now I should have all the ones loaded that I need. Now it's just a matter of figuring out what elevations those are supposed to go at. So I go back to the drawings, and I got to look and see what it says for the bearing elevation for these things. Let's see. Okay, so bearing elevation for this one is at 15. That would be in the top right corner. And it looks like it does that all the way across because it slopes from the front to the back. So what we're going to do is we're going to go back into our elevations. So we're going to go to east. And we're going to rename this one to be top of steel. Top of steel. It's going to ask if we want to rename the views. We're going to say yes. And we're going to change this offset to now be 15 feet. Okay, it automatically lowers all of our columns, which is awesome. So then we go back to level 1. And we're going to start putting some columns in. So first one we're going to put in is an 18 by 35 wide flange beam. So we got to go here, we got to go to beams, and then we got to select in the drop down what we want. So we said 18 by 35. All right, so the reference level, we're going to pick that as level 1. And then for the Z offset, we're going to put that at 15 feet. And when it says top, that means top of the beam. So we know that the top of the beam is now going to be at 15 feet. And so if I just click from this grid line here to this grid line over here, make sure it didn't reset anything. Okay, that looks good. I clicked on the side of the HSS and not the grid line, but that's okay. So I'll just redo it. So I click there. So it says that none of the elements are visible in the floor plan. The reason for that is because I need to adjust my view range. So if I escape out of everything, go back to the floor plan view, and I go to edit my view range, right now I've got it set up to where it's only looking from 1 foot above level 1 down. It actually cuts at 6 inches, so it's technically only 6 inches down. So what I want to do is I actually want to change this. So I don't necessarily need to see all the piers and stuff below. So I'm going to change this to 0 and the view depth also to 0. And then I'm going to raise this up to 20 feet. And I'm going to change my cut plane to be at 19 feet. And when I hit OK, it should show me my beam. Now it's also going to show me these slab edges. I don't know why it does that. Honestly, it's kind of weird. So I'm just going to hide that category for now. I don't need to see that. I'm also going to hide that as well. It seems to be like sometimes that these extra elements that technically shouldn't be showing up just do. I don't know why. Okay, so right now, only thing I can see are the columns, the grid lines, the reference lines, and the steel. So that's all I really want to see at the moment anyway. So we're going to go ahead and put our next one in. So I click beam again. And this one is also an 18 by 35, and this is all going to be at level 1 at 15 feet. So, I don't need to change any of the values yet. The next one down the line is a 14 by 22 because it's not running as far a distance. So I guess they thought to make that one smaller. And then the next one beyond that is also a 14 by 22. we're going to come from the opposite direction just because I get caught up in all these extra little doodads that it puts on the end in case I want to change that, which I will, but not right now. 21 by 44 is the next one. 21 by 44. There. Four legs there. And then the next one after that is an 18 by 50. So we click 18 by 50, go from there to there. And the next one after that is also an 18 by 50. So go from here to here. Okay. So we'll go back to our 3D view. You can see we've now got our wide flange beams running across the top here. They got those all at 15 feet to the top of steel, which is exactly what we want. Okay, so now we need to start putting in some of this other steel. So we'll go ahead and put in this side over here. So we'll go back to level 1. And we'll go all the way to the left side. So on the left side, the first beam is going to be an 18 by 35. So we'll go back to beam. We'll grab 18 by 35. Go to there. And then for the next one, it's a 21 by 44. 21 by 44. Go from there to there. All right. Okay, so the thing is that this roof actually slopes. So we need to make some adjustments here. So according to the drawings, this column right here, its top of steel is supposed to be at 15 foot 10 and a quarter. So this column actually needs to go up by 10 and a quarter. So what we can do is we can go back, select the column, and the top offset, we are going to change this to be 10 and a quarter inches above top steel. And then for this column down here, according to the drawings, it's going to be at 16.9 and a half. So it's got to be the difference of 15. So this one's going to be 1 foot 9 and a half above top of steel. And so if we go back to this drawing, you can see that those are now higher. And so now we need to change the steel to do the same thing. So the same offset that we put on this one, which is 10 and a quarter, is also going to be the same offset we put for the steel. So if I go back to level 1, you'll notice that on each end of the steel, it's got this 0, 0. And what that means is what is the offset of whatever level or reference level that you want that end of the steel to be. So this one is 0 because we want that to be at 15, but this side we want it to be higher. So we're going to do the same 10 and a quarter inches on this side. And then for this one, we want this side to be at the 10 and a quarter. But then this side, we're going to do the same offset that we did for this column, which was 1 foot 9 and a half. So we're going to click this, we're going to put 1 foot 9 and a half inches. And now if we go back to this, you can now see that they are sloped. So they now are all sloping to where they're supposed to. So another way that we could look at this is to look at it from the side. Perfect. So you can see that there is now a slope that is working and doing what it's supposed to. Go back down to a top-down view. Rotate that. Okay. So now we're going to put this beam in right here. That is going to be an 18 by 40. So we go back to beam, and we go to 18 by 40. And we're going to click it from here to here. Perfect. Now we already know what this offset is supposed to be. You know what? We need to adjust the view range. I think before we were in the top of piers, and what we would need it to be. Oh no, we're in the 3D view. That's why we need to go level 1. I thought I was in level 1. Guess not. All right, so 18 by 40. For some reason, this thing is not where it's supposed to be. So we need to change these offsets to be what they're supposed to be. So 1 foot 9.5. This is 1 foot 9.5. Okay. So if we go back to the 3D view, it should be what it's supposed to look like. Yeah. Okay, so we didn't change this column to be the 1 foot 9.5, which we need to do that as well. So we're going to change this to be 1 foot 9.5 inches above that, so it automatically puts that where it's supposed to be, and that's exactly what we want. Okay, so the next one we're going to put in is going to be the one that goes from here to here. Okay, so again, this one needs to be at the same offset as this one, so 10.25. Perfect. You know, we might as well just change all of these while we're at it, because these are all going to be the same. Those are all on the same plane, if you want to look at it that way, so they're all going to be at the exact same level. You know, the same thing is going to be for these ones as well. So these can be the 1 foot 9.5. And then these ones are all going to be the same, but they're going to be slightly different. They are going to be at 16.6.5, so that's going to be 1 foot 6.5. Perfect. So now we shouldn't have to resize any columns for a little bit. I do think this column here is taller, and I think that there's a reason for that in architectural, but we won't go into that right now. So we're going to do from this beam to this beam. So we need to go back to level 1. And we said that that one, according to the drawings, was a 21 by 44. So we go to beams, 21 by 44. Go from there to there. Perfect. And as we know, this side is the 10.25 inches. And this side is the 1 foot 9.5. Now, another thing that you can do, and I don't typically do it, is you can adjust some of the settings over here. You know, and not necessarily with steel, but with some of the other items, you can change the settings over here so that they apply as you're putting it in. But it comes down to which side is the start and which side is the end, and it doesn't seem to always behave the way you think it's supposed to. So I've just kind of gotten away from that. So anyway, let's see. This one is a 21 by 48. 21 by 48. So one thing we could do, though, is we could just change this to say 15 foot 10.25, you know, because that's what it is. So we're going to just put that there, and that way we don't have to change anything on the offsets. And then that beam, there is no beam right there. There's a beam there. 21 by 48 also extends from here to here. And then we've got a 21 by 44. And I'm going to change this back to 15 feet because it just makes doing the math easier. And it actually goes goes down to here. And then I will just change the offsets. So this one is the 10 1/4. This one is the 1 foot 9 1/2. All right. So there is actually a beam that is right here, but it just goes from beam to beam. It's an 18 by 35. So we're going to go to beam. It's going to ask you to save every once in a while just to make sure that you don't lose anything in the event that the program goes bad, which, it happened to me a lot back when we first started using Revit several years ago. So we're going to pick 18 by 35, and we're going to change this offset to be 16 foot 7 1/2. 16 foot 7 1/2 inches. And we just want to make sure that we're grabbing the right thing. So it's going to be on the D grid line. So D grid line right here. And we're just going to click from here to here. Perfect. And what we can do too is, you can change these extensions. So I know it's not going to literally run into the steel like that. So we're going to go in and back this up a bit so that it goes to the edge of the steel. And then if we go to our 3D view, you can see what we've done so far. Now Revit does have the ability to go in and put these structural connections, with the bolts and everything. It's a little overkill right now for what I'm trying to do. Having that high level of detail like that doesn't necessarily add anything to the model and for the project. Being able to see where the bolts and the connections are doesn't really do anything, unless you're just trying to make a really realistic model. But then that's going to increase your file size. That's going to increase, your computer's ability to compute the information. So, you got to kind of have there's some give and take when it comes to your level of detail. You really got to decide what's important and what's not. And I found that those structural connections just aren't typically worth it. So, the only time I've really caved on that is, when it comes to base plates and things, because if you want to see in a 4D simulation when the base plates are being put in and when the steel's getting put in, sometimes there can be an advantage to that, just depending on, the way you sequence things in the project. So, all right, so let's keep going. This one is a 16 by 26. So we'll go to 16 by 26, and we're going to change this value to be the 16 foot 9 1/2. Go from here to here. Perfect. Let's see. Did I miss a column somewhere? Seems to think there's supposed to be a column there, but it doesn't call out what kind of column it is. So that's one I'm probably going to have to ask the project team to tell me what type of column is supposed to go there. But for now, just so that there is something there, we're going to go ahead and just put a column in as a placeholder. You can always change it later, as we've seen. So I guess I'll have it as a 6 by 6 by 5/16, and put it right there. It's going to say that we can't see it because it did the same thing as before. So we're going to go to top-down view, grab it. We're going to say it goes to level 1 to top steel, and the offset for the top of this one is going to be at 5 foot 2 1/2, because this is like a tall canopy type thing. It doesn't look all that much taller, but it is. It is taller. It's quite a bit taller. All right, so some of these HSS columns actually have where the steel connects on a high level and where it connects on a lower level. So why don't we go ahead and change the elevation of some of these to reflect that. So that one stays the same. However, this one, the top of steel on this one is at 20 foot 2.5, so that would be 5 foot 2.5. All right. And then this one also has a high and a low. So the high on this one is also the 20 foot 2.5, so this is also the 5 foot 2.5. All right. Now it does say there's supposed to be a column right here. There's a column right here, but it doesn't tell me what size the column is. And not only that, it doesn't really locate it very well for me. So that's another one that I'm probably going to have to ask the project team to get with the architect and get some answers, because it doesn't even show the column. It just says what the top of steel is supposed to be. And I know that steel is not just going to be cantilevered, it's going to be sitting on something. So I'll have to ask on that one. But the interesting thing there is since I don't know exactly where that goes because it doesn't line up with the grid line, I don't know where to put it. So I can't place that one for now. So all the steel associated with this little canopy area is going to have to kind of be on hold until I can figure out exactly where that steel is supposed to go. But that's okay. That shouldn't stop us from doing what we're doing, so we're just going to keep going. So we're going to put this steel in here. This was the little itty bitty one. It's 10 by 12. So we're going to go to beams. We're going to go 10 by 12. We're going to change this back to 15 just to make it easier for when we need to do the math to make the adjustments. Just like that. So this one we know right here is going to be the 1 foot 9.25. Should be 1 foot 9.5. I think that's a typo. We're going to say 1 foot 9.5. We're going to keep it all consistent. There's not really any reason to drop it 1/4 inch when it's technically on the same plane. Let's see, and then this one, according to the drawings, the low end is at 16 foot 6.5, so that would be 1 foot 6.5, 1 foot 6.5, which makes sense because it lines up with all these other ones and they're in the same plane. Okay, so now we've got an 18 by 50 that goes here. So 18 by 50 goes from here to here. Okay, we know this one is the 10.25. And we know that this one is the 1 foot 6.5. Okay, we gotta put this beam in right there. That's a 16 by 31. Oh, did we not grab a 16 by 31? I think we missed the 16 by 31. So let's go ahead and go grab that real quick. So we'll go to Insert, Load Family. You always think you got them all, and you always end up missing something. So that's okay. We'll go grab it. 16 by 31. So pull that in. Go to Beams. There's 16 by 31. We're going to go ahead and change the offset here so that it's the same as the other ones. So this is going to be the 15 foot 10.25. Go from here to here. Alrighty. See, the next one is a 14 by 43. Or, yeah, that's the one where it's actually a 34 because they're dyslexic. Okay, and then we're going to do the 18 by 50. We're going to change this back to 15, so that way our offsets and the math is easy. So we'll change this one to 10.25. change this one to 1 foot 6.5. All right. Now this one right here, this actually is not a wide flange beam. This one is a hollow steel. So we got to go grab the right hollow steel that we loaded, which is the 16 by 4.25. And it says that it is at 22.5. So that'd be 5 foot 2.5. So we need to change, we can just change this to 20 foot 2.5. And it goes from here to here. I'm actually kind of surprised that it shows up because we changed our view range to only be at 20 feet. That's okay. You know what? We're going to raise this up a little bit more. We're going to go 25 feet. And we'll change this to 24 feet. Just to make sure, let's go to our 3D view, make sure it all looks right. Yep, it all looks right so far. So this little canopy area here is, I guess, elevated above everything else, just as an architectural feature, you know, because architects love to do that sort of thing. All right, so let's put in that beam there. It's a 24 by 55. Go down to 24 by 55, which is the biggest one we got. And we're going to change the offset to be 16 foot 10.25. Go from there to there. Seems like an awfully big beam to be connecting to such a small hollow steel, but you know what? I didn't design this thing, so it is what it is. All right, so we come down here, and we've got a 21 by 48. We're just going to go ahead and put all these in so we don't have to keep changing the elevation. And then the last one is the 24 by 55. Just like that. You know what, while we're at it, let's go ahead and put all these ones in that are at the same elevation. So the first one's going to be an 18 by 50. And we'll change this to be the 16 6.5. Goes from there to there. Next one is an 18 by 50, and it goes from there to there. And the last one is also an 18 by 50. So it goes from there to there. Perfect. All right, so we got those in. Now we just got to do these beams that kind of cut across. Okay, so we've got an 18 by 35 that goes there. We're going to change this offset back to 15. We can change this to be the 10.25 inches, and we can change this one to be the 1 foot 6.5 inches. All right. And the last one is also an 18 by 35. The cool thing here is we can actually just copy this beam because it's the exact same beam. We're just going to copy it over to the grid line. So I used a hotkey command there. I didn't go up here and click all these buttons. When you've used Revit for a while, you're going to learn all the hotkeys. You know, and if you want to know what a hotkey is, you can just hover over an icon and it will tell you what the hotkey is. So for rotate, you can see it's RO. For trim, it's TR. Let's see, for move, it's MV. If you want to copy something, that's CO. So CO is copy, and then OF is offset. So you know you can just, and AL is align. You can just learn these hotkeys, and it'll make things way faster. Okay, so let's go up here. We've got another 18 by 35 that goes from here to here. This is at the 10 1/4 offsets, and this side's 15, so we're not going to change that one. And I need to look to see, yeah, so there's an 18 by 35 there as well. So we're just going to CO, click this grid line here, and say we want to move it to this grid line here, and voila, we've got another 18 by 35 that already has the correct offsets on each side. Just going to quickly scan through my drawing here and make sure I haven't missed any. Okay, so we actually do have one that's right here, but that is also an 18 by 35, so we can just do the same thing. We can copy from this grid line over to this grid line. And that's going to be it for the wide flange beams. So let's go ahead and go back to our 3D view and take a look at what we got so far. So it all looks pretty good. Now we're going to put in our KCRejoice. And I have kind of I have a weird way that I do the KCRejoice. And I know you guys in the comments are probably going to say that's the wrong way to do it. And I totally understand. I don't even know why I do it this way. I think it's just because it automatically creates the spacing for me, but then I don't necessarily want them to be part of a beam system, so then I go back and I delete the beam system. And plus I have to go in and I got to change the offsets, and I really can't do that while they're part of a beam system. So I apologize if this annoys you guys a little bit, because I know it probably will annoy some of you because I'm not doing it correctly, but you know, that's okay. We all do things different ways, so it's all good. So I got to go and I got to count here. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I've got 11 28 K9s that need to go in. So I'm going to click Beam System. For the beam type, I'm going to say it's a 28 K9. And I'm actually going to say there's a fixed number, and I'm going to say there's 11. Justification is on the center, and we're going to just highlight next to this beam, and you're going to see it's going to automatically figure out exactly where those need to go. So if I just click it, it's going to automatically create my KCRejoice. For some reason it's saying that they're not showing up, but I can just come in here, click on this, and say, oh, that's not going to work. Let's try that. Let's go to Visibility Graphics, and we're going to say all, and I'm going to click it so they all go off, and I'm going to click it again so they all go on. That didn't work either. Oh, you know what? We need to change the elevation. That's the part I probably forgot. So we need to change this to be 15 feet. There we go. Sorry, I forgot that little detail that I needed to change the elevation. Okay, so what I'm going to do is I'm going to go through and click all of these. And I'm going to turn off the pins, or you could just come up here and say unpin. It'll do the same thing. And once I unpin it, then I can actually go in and change this value here. So I'm going to go in and change all of these to be the 10 1/4 offsets. You know, I changed that to feet. That's why that looks so weird. Probably going way up there. And I know you guys are all probably thinking, like, this is such a tedious way to do this. Yeah, it kind of is. I'm not going to disagree with you. But feel free to leave some comments down in the description or down below. You know, a better way of doing this. You know, like I say, I'm always open to learning better ways of doing things. I've just found that if I keep them in a beam system family, it's not as easy to change the offsets on the sides. When I've got a slope, it works great if it's all flat, but when you got the slope thing going on, it just doesn't seem to work as well. Because if I go to the beam family here, it doesn't really give me a whole lot of options on how to change the offset. So I found that if I break them back up into not being pinned, then I can change the offsets. So it's just one of those things. Let's see. So let's go ahead and do the next one. Next one, they are also 28K9s. I just need to figure out how many of them there are between beams. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 in the next set. So I go to beam system, change this to be a 15. And if I highlight next to the beam, because if I highlight this beam, then they're going to go the opposite direction that I want. So I got to come next to this beam, so that way they're facing the right direction. I probably should change my elevation beforehand, though, because I made that mistake last time. All right, so if I click next to the beam, they should show up. There they are. I'm going to click all of these so that I can change the slope on them. Okay, I'm going to unpin it. And if I change this one to be the 10.25. So another thing that you can do too, I need to change that to inches, not feet. 10.25 inches. There we go. So once I've changed one of them, so this is a way this could go a little faster. You can come over here and you can see which side is the start and which side is the end. This goes back to what I was saying before, is I don't know which side it's going to have as the beginning or the end until I come and I change one of them. But now that I know that the end level is the one that needs to be raised, I can actually come in and I can click all of these. Just like so. And then I could just come in here and change the end level offset for them all at the same time. So, I mean, that definitely saves some time. So if I click on these, you'll see that they are all now at the 10.25. Okay, so I need to do the next one. And this last one is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I have 13, and they are also the 28K9s. So I just changed this to be a 13 instead. Make sure my 15 feet's there. Click next to the beam. They will show up. So I just go through and I click all of these. And then I'm going to unpin them so that way I can change their offsets. Now I can assume that this is going to be the end because they were before. So let's just make that assumption that these are all going to be the ends on the right, on that side that I need them to be. And let's click on one to find out. Yes, absolutely. All right, so that's great. All right, so then let's jump down to the one below it. And we know that this one has 13, but these are 22K5s. So go to beams. We're going to change this to 20. Did we not grab 22K5s? My goodness. There's another one that I missed. All right, so we're going to exit out of this. We got to go back to insert. We got to go to KCRejoice. And we got to grab a 22K5 because I apparently did not grab that before. All right, go back to structure, go back to beam system. You know what? Maybe we did grab it and I just didn't see it because it was up here because it's doing all of this alphabetically. 22K5. We know there's 13. That's 15. All right. So we're going to click next to the beam. Perfect. We're going to go ahead and click all these. I'm going to unpin them. Now I'm going to assume that this is the end and this is the start. Just because that seems to have been how it worked before, so we'll just hopefully that is correct. 1 foot 6.5. So let's make sure. Yep, exactly what it was supposed to do. Perfect. All right, so the next series here is going to be 22K5s, 1, 2, 3, 4, 5, 6. So there are only 6 here. So we go to beam, say that there are 6. All right, click in there. Going to unpin them. We're going to change the offsets. Just like so. Make sure that looks right. Okay. Now this is actually void right here. They don't have anything in that space. So that's just open. So we'll skip that one. We'll come over to this side. And there is 1, 2, 3, 4, 5. So there's only 5 in here. But they are 26K7s. All right, so you'll notice that if I go next to the beam, it is not doing what it's supposed to. And you know, this sort of thing happens, especially when you're not going from a column to a column, you're going from beam to beam. So instead of doing the automatic beam system, I'm going to click on I want to sketch my own beam system. And so what I'm going to do is I'm going to click the square, and I'm going to go from the center of that column to where these grid lines intersect. So it's basically saying center, center, center. Now I don't want the beams to go this direction. I want them to go this direction. So I'm going to change my beam direction to be going vertically and not horizontally. Click OK. And there they are. Now the only problem with doing it yourself is that now I've got to come in and delete all these tags because I don't want to see the tags. I'm not planning on producing a set of drawings with these, so I don't need to see the tags. It's just for 3D purposes. Okay, so then I'm going to change this offset. Now this will be interesting to see if this actually does what it's supposed to, or if it went backwards. Okay, so this time it went backwards. So you'll notice that it flipped it around the other direction. So, you know, that's a simple fix. You know, I'll just grab all of these. I don't need the beam system though. Oh, it's also grabbing that. Okay. You know what, maybe I just better click them. I thought I could do the whole, like, grab them with a window, but apparently I was grabbing other things that I didn't want. Okay, so then we're just going to flip-flop these around the other direction. 6.5.5, 10.25. Okay, so now we've got those facing the right direction. And then we've got this last little bit right here. Oh, you know, we skipped this one right here. We need to do this one too. This one's actually a 30K7, and there's only 4 beams. 30K7, and there are 4. Just like that. All right, so given the fact that we know that when we highlight next to the beam and create it, it does actually put the justifications where we think they're supposed to be. So this is where it's the 1 foot 9.5 on this side. Let's just make sure. Yep, that looks right. Okay, now this is the last one. This is a 30K7 as well. And there's 5 of them. So change this to 5. Click inside. There they are. Unpin them. Change the offsets. Make sure. Oh, see, now it's got swapped. Now it's going in the opposite direction. I'm telling you, it's totally random which side it decides to do it on. 1 foot 9.5, 10 1/4. So we're going to switch those around. Okay, that looks right. Okay, so let's go to our 3D view. Let's take a look. Let's make sure it all looks okay. It all looks okay so far. So one thing I did on the fire station is the beams that were on the sides that were parallel to the joists. I kept those where they were, but then the wide flange beams that were perpendicular, I actually ended up lowering them by 2.5 inches, so that way the joists were actually resting on top of the beam, so that the top of steel was at the right elevation. So I'm going to do the same thing. So for these, I am going to lower them by 2.5 inches, which is pretty much the width of that seat for those joists. So if I come in here and I say put an equals in front of this, and then I say minus 2.5 inches, it'll do the math for you, so I don't have to do the math. So I just hit tab, and it'll automatically figure out how far down that has to go. And so if we look at it now, you'll notice that these should be sitting pretty much on top of the beams. And I might need to do a section cut to figure out if that is, where that needs to be. Maybe it's not 2.5 inches, maybe it's something else. But, that's stuff that we can play around with. I'm going to do the same thing for this one as well. So we're going to lower this one by 2.5 inches as well. Oops. I do really recommend you use a wireless mouse when you work with this program, because I've really struggled with wired mouses, and the fact that, because if you move the mouse outside of this side window, it'll update whatever changes you were trying to make. So, if you're making changes over here on the left side, that you need to put all of them in before it updates, otherwise it's going to cause problems with some of the parametric stuff. It's best to use a wireless mouse, because as soon as you let go of the mouse, if it's a wired mouse, the wire on the mouse might actually move it outside the window. So when you click in a cell and you let go of the mouse to go type, it might actually move your arrow outside that window. So that's why I like wireless mouses, is because as soon as you let go of the mouse, there's nothing to move it. So that's just one of those things that I found is definitely very helpful. Let's see, we're going to change this beam as well. So this beam we're going to bring down. Let's see, did we change offsets? We did change offsets. 1 foot 9.5, 1 foot 9.5. Okay, so, oh, no, that did what we wanted. Okay, so we just need to change, let's change this to be 16 foot 9.5. And then we'll change these to be 0. Which essentially is means it's not going to move. It should be exactly the same. Although it did affect how these joists are connecting though. Let's go in here and see what this did. Oh, so we just need to change this back to 1 foot 9.5. Yeah. Okay, so now we can change. Let me just make sure we didn't do the same thing there. Okay, we didn't. So sorry, I had to change the settings on this one because rather than just putting the actual elevation when I put the beam in, I changed the offsets. And since I didn't do the same thing for the other beam, it wasn't giving me the same options on the left side because the way that they were installed or placed was different. So I had to make it so the way that they're placed is the same using the elevation, the true elevation, and not the offset. So that way I could go in and do what I needed. So sorry, I know that was kind of a long explanation, but all right. So go in here, I can say equals minus 2.5 inches. Okay, so now that's changed. And like I say, I may need to come back later and change, maybe it's not 2.5 inches, maybe it's only 2 inches, I don't know. Okay, so we're going to change this one. So, I mean, we can just do the math here. It's 16.4. Okay, and then we can do the same thing for all these back beams. So we'll say equals minus 2.5 inches, 14.9.5, just like that. Alrighty. So that all looks pretty good so far. I think that we've done some good work on this so far. We got structural steel in there. The next thing is to start looking at some of the walls and maybe some of these other steel members, making sure that they don't have different upper offsets that we need to take into account. One last thing before I go for this particular episode. Go ahead and save. I'm going to cut a section plane or a section cut because I want to take a look. Usually whenever you do this, it's going to automatically take it as far out as it will go with whatever 3D objects you have. I don't want to do that. I want to back it up so that I'm only looking at only like one tiny little section. I don't want to look at the whole project. So we're going to move this so that I'm looking at a joist. And then if I click out of it and then double click on the arrow, it will open up that view for me. Now right now it's not seeing all the steel up above, so I need to pull this up so that I can see it. And I also need to change my detail level to be fine so that I can actually see the web joist. And then I want to change this to shaded so that stuff pops out a little bit more at me. Okay, so the reason why it looks like they're not resting on this beam is because they're not. So I probably need to go in and adjust, how far these things are extending. Actually, probably what I need to do is just move the whole thing up a little bit. That's probably what I need to do. Is just adjust these so that they are technically resting on the center of the beam and not on the edge of the beam. So, that's something that would not be too difficult because I can move all of them at the exact same time because they all have the exact same problem. So if I come in here and I say from here to here is 4 inches. So I can draw a detail line, and the nice thing about the detail lines is they are specific to that view, so they won't really show up all over the place. And I don't have to tell it what reference plane that these lines are being drawn on because technically they're being drawn on top of the view, which is nice. So I'm going to draw a line from here to here. And then I'm going to try to find the center of that line, which is right there. And then I'm going to draw a line up, and it's going to tell me if it's perpendicular. You can see by that little square shape that it makes, and then it will actually say it's perpendicular. So I want to draw a perpendicular line. Actually, you know what? I don't want to draw a perpendicular line. I want to draw a line that is straight up and down. So we're going to draw a line that's straight up and down. Because it doesn't need to be perfect, right? It just needs to be close. So we're going to draw, or make a dimension from there to there. So 1 and 11/16. So if I was to even move them over like 1 3/4, that would be totally fine. So now we're going to go back and delete our lines. And then we're going to go back to level 1. And we're just going to say select all instances visible in the view. And we're going to say move with MV. And we're going to go down by 1.75 inches. All right, so we got those moved. And then we're going to say select all of these instances. We're going to move those down 1.75 inches. And then we're going to select all of these instances. All right, so that should have been all of them. Let's go back to our 3D view here. It should now look like they're sitting on top of them more than they were. All right, that's not bad. Let's go back to our section cut and just make sure that it doesn't look too bad. So that looks like it's sitting on the center. And this side looks like it still needs to be shifted more, but that one's on the center. So these should really be sitting on the edges. So these probably need to move more than what I've actually moved them. So let's just look at this one more time. If I draw a line straight up, go from here to the center of the beam. So 1 foot 1 and 29/32 inches. So if I probably moved them up 2 inches, that would be fine. I mean, like I say, it doesn't gotta be perfect. So let's go back and do what we did before. We're gonna select all instances. We're gonna move them down another 2 inches. Okay, so now we've run into a problem where it's saying that now we can't keep things joined because it thinks that it's now moving off the beam. So it's thinking that it's no longer. So let's just, for now, let's just say unjoin. Okay, because I want to take a look and see what that exactly means. So let's look at these and see how far off the beam did it move. Okay, so it looks fine. Really what that was is the beam system, which I didn't end up deleting. It thinks that the beam system got moved. And while technically it did, it got moved to where it was supposed to be. So we're going to do the same thing with these other ones now. So we're going to select all instances. Move them down 2 inches. Select all instances. Move them down 2 inches. Select all instances. And move them down 2 inches. All right. So we'll go back to our section cut. Looks pretty good. Looks like everything's sitting where it's supposed to. Yep, looks good. Looks good. And our 3D view looks a lot better. Now this one, it's like, I don't know exactly how. I think there's probably like some sort of angle iron that this is going to have to attach to. Another thing I'm going to have to look at is the spacing, because when I put these joists in, I just let it use the automatic spacing. It automatically spaced them all out evenly. But I need to look at the drawings again, because maybe there was some specific spacing that needed to happen with some of these joists, and so I need to go and start moving some of them around to where they're really supposed to be. But at least it got them in there using the beam system, so I don't have to individually put them in. I can put them all in at once, so that helps. But yeah, I think it looks good. I think this is a good start. So I'm going to kind of leave this episode with that, and next time around we'll look at maybe start to do some of the architectural, or maybe we'll jump back over here to structural and look at some of the things that we need to tune up a little. But I appreciate you guys for joining me, and hopefully we'll catch you on the next one. Talk to you later.